Good morning, sir.
Good morning, Raj. Okay, just wait for 2 minutes. I'm just doing the stuff. Just wait for 2 minutes. Okay. Okay, so let we will start. Again, very good morning to all of you. Let me share my screen first. And I hope you have clear with the idea that we have discussed in the last lecture. Yes. So is the screen visible to everyone?
Yes, sir.
Okay, great. And can anybody tell me what we have discussed in the last lecture? Something revised, some revision. What we have discussed in the last lecture, can somebody tell me? So out of this entire class, that how many students are I think there are from the next Monday, your physical classes are also started. So can somebody tell me that, or somebody write their opinion on chat box that how many students are planning for offline, how many are planning for online? Please tell me. Type it in the chat box. What is your opinion and what you are planning to do? Everyone, quickly. Online. Okay. So majority of them having opinion of online, and some of the student few has targeted for offline. Jenny, okay. I got the idea from majority. So in a last lecture, what we have discussed about the basic difference between I can say time domain representation and frequency domain representation. As well as we have discussed about the several stuff like uh, how the any analog signal or any periodic signal is going to represent, and what are the basic three component of any particular analog signal, which is a I can say that's a frequency, I can say, then I am having amplitude and the phase. Okay. Then we have discussed about the concept of wavelength. That what do you mean by wavelength? Okay, how we can identify the wavelength. Can anybody tell me over here what is the meaning of wavelength? What do you mean by wavelength? And what is difference between wavelength and frequency? You should be interactive, okay? Don't be sit ideal. Whatever wrong answer, right answer, I don't any problem with that. But whatever you know, please share with me. What is wavelength? What is frequency?
Sir, it is inversely proportional to each other. I mean, if frequency will be greater, then wavelength will be shorter, and vice versa.
Yeah, true. It's exactly true. But the equation, like it's inversely proportional, but the constant, yeah. So Raj says the distance between two adjacent peaks through the wave, okay, that we can also say as a wavelength, as well as we need to identify that wavelength is going to measure in terms of any medium. Okay, so yeah, lambda is equal to c by f. So it is a kind of the inversely proportional to both of each other. Sorry, but you need to take care of constant c, and c is nothing but your speed of light. So whenever you want to identify the lambda, you need to take care with a ratio of frequency of light in a free space, which is a c, and whatever the frequency you have. And frequency you can get it from the time period. And what do you mean by time period? What do you mean by time period? T. How we can get a frequency from a time period? Yes, someone, please. Yeah, time taken to complete one cycle. True, Raj, yes. So one cycle will take how much time to complete their one cycle? Okay, so we can say that one cycle is getting completed in, let's say, t time. So 1 by t is your frequency. And if you're having that frequency, yeah. And if you're having that frequency value, and that c is going to constant. So you can identify the lambda also. So these are the equations we have. through which we can identify frequency, wavelength, and all the stuff. As well as we have discussed the stuff related to time and frequency domain representation. So I can say there are a time domain representation with specific amount of amplitude, with specific amount of frequency, is going to presented with the one spike in a frequency domain. And you have done a exercise also at the end of lecture. I have shown you the exercise also. So I think that all of the thing is going to be clear. Any doubt in the last lecture? Any doubt, anything in the last lecture? So please tell me. No? Okay. Let me move forward for this particular diagram. So this diagram is very well, we have discussed in the last lecture also, that DC signal having a no frequency. So DC signal having a zero, no frequency, it means we can say there is a zero. So there are a zero, DC signal is present in a frequency domain as a zeroth, or we can say in a kind of a zero position of your frequency axis, and their amplitude line you need to draw for that. So the blue line is draw like this one. As well as you can say there are 8 volt of the, there are 10 volt of the 8 hertz signal is represented with this spike line. As well as there are a 16 hertz signal with the amplitude of 5, which is present like this one. So this is a time domain representation. This is a 16 domain representation. But if you remember this diagram, you will get idea that how the time presenting, and to equivalent to that how frequency presenting. Now next signal, or we can say next type of the important stuff we have, which is a composite signal. Okay. Now composite name itself says, what do you mean by composite? Can anybody tell me? It's already written over here in a diagram. Composite. What do you mean by composite? Okay. So composite signal is nothing but, as it is shown over here, any composite signal is combination of simple sine wave with different frequency, different amplitude, and different phase. So let's say you are having a 3 signal you have. Okay. Like you can directly consider this one. Like there are a 3 signal, each having a different frequency, having a different amplitude, might be the phase is also going to differ. So when you combine all these 3 signal and present only one, okay, at that time it is considered as a composite signal. Now how to combine it, or how to we can say give their combination of both of all of them, okay, that we need to understand over here. So if composite signal is periodic, then decomposition of this particular signal will give the discrete frequency. If the composite signal is non-periodic, the decomposition give the combination of sine wave with the continuous frequency. Now what is the meaning of this particular diagram we have? Okay, here this is a I can say like just give me a minute. Okay, everybody give me a minute. Let me just draw something so I can explain you over here. Give me a 1 minute. Just let me just connect my MOSFET with this one. Okay, so how the signal is going to generate it, such type of the thing is going to be generated, that we need to understand. So if we go to the downside of this particular signal, so we can take an example of such a simple sinusoidal wave. Okay, now what is a simple sinusoidal wave we can draw over here? Let's take there are two signal we have. Let's take it is having a frequency, or we can say the signal like this one. Another signal which is going to be like, so here there is a 1 cycle completed, while in the second signal there are a 2nd cycle is completed. So how the composition of this both signal is going to be formed, and how the signal will look like? The signal is going to be look like by adding their amplitude at everywhere. Okay, So whatever the amplitude of both of the signal, that is going to be added in both of the case. Like you can say, so if you just take a small disk, I'm just taking for the example, like if I'm just taking a small point, and when I'm going to multiply this both of the signal, so how I can get the idea? So whatever the signal that I'm initially it is getting rising, then it is rise, and at the middle it is going to be a 0. Okay. Then again it is going to be negative. So we can say there are another spike will be there. Likewise, there are some composition will be created like this one. Okay. Sorry for this one. So it will be like this one. Initially it is go up, then it is multiplied it with that, and it's going to down. Then again there are some spike. And whenever both 0 is going to came, that signal is going to 0. Then in negative side it is going to down like that. So original signal will be like this one. When you multiply it with that, so whatever the spikes are there, which is generating from the multiple frequencies, while your overall major frequency is going to be the periodicity in this manner. Okay, so whenever we identify that, how this composite signal is going to create it. So you can see over here, like whatever this both of the signal we have, 10 hertz, 8 hertz and 16 hertz. This signal is periodic in manner. So when both periodic signal combine with each other, obviously your composite signal is also get periodic. Are you getting my point? Yes or no? When both signal getting periodic is going to combine with each other, output final is also getting periodic. Okay, because why it is going to be also periodic? Because it is going to change their same property. So जो भी ये duration में जो भी variation होगा आपका signal का, like this one, okay, that same variation is going to be repeated after some cycle. Okay, so we can say whatever the amplitude variation is there due to the one complete cycle, that is going to be repeated after every cycle. So we can say that composite signal is also getting a periodic like this one. So it is also saying like that, if composite signal is periodic, the decomposition gives the series of signal with discrete frequency. Meaning of that, it will be look like this one. Let's say we are having a first frequency f, which is mentioning with this one. This is a blue line. A pink line, sorry. Then we are having a blue line 3f, so we can say that frequency 3 times faster than over that previous one. Then the frequency 9f, so there is another 9f, but their amplitude is smaller. So when you decomposite this signal, it is already look like there are a one frequency spike at a f, another frequency spike at a 3f, and another frequency spike at a 9f. Okay, amplitude is differ. Why? Because over here this amplitude, and this amplitude is also differ. So in frequency domain also this frequency going to be the frequency going to be same, but their amplitude is going to be differ in terms of representation. ये समझ में आ रहा है सबको? पीरियोडिक सिग्नल अगर कंबाइन होगा तो आउटपुट भी पीरियोडिक होगा. इसका मीनिंग ये हुआ कि पीरियोडिक सिग्नल का जो भी फ्रीक्वेंसी रिस्पॉन्स है वो डिस्क्रीट ही होगा. क्यों? क्योंकि वो पीरियोडिक सिग्नल से बना हुआ है, और पीरियोडिक सिग्नल के लिए फ्रीक्वेंसी रिप्रेजेंटेशन कैसा होता है? It's a spike. So we can say there is a series of discrete component in your frequency domain. फ्रीक्वेंसी डोमेन में ऐसी स्पाइक वाली बहुत सारी फ्रीक्वेंसी होगी in your periodic composite signal. ठीक है? So periodic composite signal will give you the series of discrete frequency spike in a frequency domain. This is a one sentence you need to keep in mind. Any doubt in this one?
No, sir.
Okay. Now let's moving towards the next one. So if the signal is going to be a non-periodic, okay, so this signal is considered as a non-periodic. How you can say non-periodic? Can anybody tell me why we can say this is non-periodic?
Sir, the representation of wave is not repeating after a certain interval of
Yes,
time.
true. So we can say whatever the wave representation over here, it is not repeating after a specific period of time, and it is a look like a random signal while their frequency is not fixed, their amplitude is all not fixed, and their phase is not also fixed. So it is a mixture of, I can say there are any random spikes, random amplitude, random phase, and all the stuff. Okay. Now, how I can identify the frequency domain of this signal? Okay, so to identify the frequency domain of the signal, first you need to find out that whatever the signal which is that you are transmitting or that you are presenting over here, you can consider like that there are one box you have. Okay, and you identify that you are giving the signal to this particular box, and from the output you are measuring the frequency of that, and that box is going to be like the spectrum analyzer. Okay, like spectrum analyzer or any such type of the meter you have. So by looking to that meter, you can say what is a minimum frequency of that, what is a maximum frequency of that. Okay, and at which particular frequency your amplitude is going to be higher or its amplitude is going to be lower. Okay, so this type of the random signal will give you not a discrete frequency, it will give you the continuous frequency band. And why it is continuous? Because you don't know that in this particular signal, between this 0 to, let's take this overall signal will show you that there is a maximum of 4 kilohertz frequency. Okay, so starting from 0 kilohertz to 4 kilohertz, your signal is going to have such type of the constant frequency response. Okay, so there are an entire band is there, and any frequency can be possible in this one. Why? Because you cannot predict any frequency, so it is not allowed to do a such type of the discrete frequency band. But rather than this discrete, it is just like a continuous band because it is representing all the frequency in this band. So the conclusive part over here, like non-periodic signal, non-periodic analog signal will give you the continuous frequency band. So this is a sentence for non-periodic analog signal. What is a sentence for the periodic signal? What is a sentence for the periodic signal? In a last, we can write it like that: periodic composite signal gives discrete frequency band. So there are two lines you need to keep in mind. Periodic composite signal, better I can write analog. Periodic analog composite signal give the discrete frequency band, while non-periodic composite analog signal give you the continuous frequency band. And what is the reason behind that? Because in non-periodic signal you cannot predict the any frequency in between a maximum and minimum, so you need to give the continuous spectrum. While in a composite periodic signal, you can say that there are such three frequencies associated to create such composite signal, so you just need to give a 3 spike of them, which is a presentation of such periodic composite signal. So these are the stuff we have which is related to bandwidth, periodic and non-periodic. So this is the overall, I can say, comparison between them. So what is the bandwidth of both of the frequency? Let's consider that whatever the signal that you are presenting, it is having a maximum frequency of, let's take 5 kilohertz, minimum having 1000 kilohertz. So this is a range of maximum and this is a minimum. And what do you mean by bandwidth? Bandwidth is nothing but difference between maximum frequency minus minimum frequency. So I can say what is a bandwidth, which will be like this one, 5000 minus 1000. So this is a bandwidth of your signal. And the same rule is applied over here also. Maximum frequency 5000, minimum frequency 1000. So their bandwidth is going to maximum minus minimum 4000 hertz you have. Well, this signal representation of periodic signal with discrete points. Well, this is a frequency representation of non-periodic signal with the analog variation. Is it okay? This is a analog frequency. This is an analog signal we are talking about, and this is a frequency of or with frequency response of composite periodic signal, composite non-periodic signal. Any doubt so far? Any doubt so far? Please tell me if any doubt, like sir, this we have not got. It is look like right now it is look very easy that this is a stuff, this is a stuff. But when we are going to see when we are going to ask the question, you should keep something in your mind that this thing I need to just keep in mind this sentence. That's why I'm writing this sentence, that what is periodic, what is non-periodic. Just a second, let me drink a water. Okay, chaliye. What is the next stuff we have? Now we are coming to the stuff of digital signal. Now what is a digital signal? Can anybody tell me the definition of digital signal? What do you mean by digital signal? Speak up, please. Definition of digital signal.
Sir, a wave which has two amplitudes
Okay.
as a minimum and a maximum, 0 and 1.
Okay. That's the one thing. Another standard, like there are some signal also over here. As you see in this screen, there are 4 amplitude. Level 4, level 3, level 2, level 1. So there are 4 amplitudes. Still it is considered as a digital. So it is not like just only 1 and 0 is a digital, but there are some levels, such type of the level signal are there, which is also going to digital. The wave is constant at a instant time. It is only having a 2 value, high and low. Okay, the wave is a constant at an instant time. So Vishal, there is a related to that same definition I'm saying with that. The definition of digital that we can repeat over here, which is having a discrete time and discrete value. Okay, so we can say for specific period of time t, your signal is going to maintain the same value and it is not going to change for that particular time period. That is considered as a digital signal. Discrete time, discrete value. While what is the definition of analog signal? Continuous time, continuous value is going to vary. While in digital signal, discrete time, discrete value. So meaning of that, for a specific period of time, your value is going to constant. It is not going to change in that period. So that is a definition of digital signal, while we can say discrete time, discrete value. In a simple word, थोड़े टाइम के लिए आपकी जो वैल्यू होगी सिग्नल की वो कांस्टेंट ही रहेगी, उतने लेवल तक ही, आइदर वो 0, 1, 5 वोल्ट, 4 वोल्ट, 2 वोल्ट, 3 वोल्ट, -5 कुछ भी हो, बट वो उतने टाइम पीरियड के लिए कांस्टेंट ही रहेगी. वो 5 की 5.5, 5.9, 6.2 वो नहीं होगी. It's a constant that level only, that considered as a digital signal. Okay, so over here there are 2 type of the digital signal which is showing. As it is said, there are 2 level signal and 4 level signal. So definition by we can say digital signal. For example, 1 is encoded as a positive voltage, 0 as a 0 voltage. A digital signal can have more than 2 level. In this case, we can send more than 1 beat for each level. So this is a standard signal like 0, 1, 0, 1 variation. 1 is present with the higher voltage, 0 is present with the lower voltage. So like 1, 0, 1, 0 present like this one. Now sometimes there is a requirement is there, whatever the time period, like we can say there are a word which is mentioned over here, beat rate. Okay, beat rate. Now what is a beat rate? Beat rate will tell you that how many beats are there, how many beats are transmitting in 1 second, beats per second. So you can say in a 1 second, if you are transmitting how much bit? 1, 2, 3, 4, 5, 6, 7, 8. So your beat rate is going to 8 beat per second. Okay. So now there are a definition of beat rate that you can get it clear with that, like number of beats per second, that's a BPS. Over here is 8 BPS. Somebody say like that, I want to transfer data not with 8 BPS. I want to transfer it with the 16 BPS. Time is going to same. Frequency of the signal is also going to be same. Now over here there is a word is coming as a frequency, or we can say pulse. We can say pulse that width. Okay. So consider like that. Consider, we can say like you are having a laptop. So in laptop there is one specific gigahertz frequency you have. Let's take your laptop is having a stuff of, let's take 3.2 gigahertz frequency of laptop is there. So what this 3.2 gigahertz is identifying, this 3.2 gigahertz. So from this frequency F, can you identify the time period, which is 1 by 3.2 gigahertz. So whatever the time period you have, can anybody tell me what is 1 by 3.2 gigahertz? Giga, it means 10 raised to 9. 1 divided by 3.2 into 10 raised to 9. Can you tell me what is a T? What is the value of T? Calculate, फटाफट चलिए. चलो 1 divided by 3.2 ही करना है ना. 1 divided by 3.2 multiply by 10 raised to minus 9.
सर चैट में लिखा है.
चैट में लिख, बोलो ना यार, चैट में क्या लिखते हो? 3.125. So it is like 3.125 into 10 raised to minus 8. Can we say like that it is a 0.31 into 10 raised to minus 9? So we can say it is nothing but 0.31 nanosecond. So 10 raised to 9, it means nano. Okay. So the pulse rate, or we can say whatever the time period between these two particular consecutive pulse, which is a 0.31 nanosecond. Okay. So each pulse which is representing either 0, 1 or that one level is only having a 0.31 nanosecond. Okay. Are you getting my point? Where this, what is the distance, or we can say what is how the frequency and how it is come to this particular pulse width. So you have a pulse width of 0.31 nanosecond. So such 0.31 nanosecond of the pulse, and such pulse is going to coming in your 1 second. Okay. So now 0.31 nanosecond you have. Okay. Let me just go with this little bit of 0.31 nanosecond, which is your pulse rate. Can you tell me how many pulses are there in 1 second? .31 nanosecond pulses are there. Can you tell me how many such pulses are going to come in a 1 second? एक पल्स की ड्यूरेशन 0.31 नैनोसेकंड है, तो एक सेकंड में कितने पल्स हो गए, कितने पल्स आप ट्रांसमिट कर सकते हो? Can anybody give me the
0.
how many pulse?
सर चैट में अंकुर ने लिखा है
0.31 into 10 to 9. True, which is a 0.31 multiplied by 10. 0.31 multiplied by 10 to 9. How you have come up with that particular solution? 10 raised to 9. 0.31.
सर नैनो सेकंड
सर नैनो में से
हाँ?
नैनो में से सेकंड में कन्वर्ट किया.
Okay, so you can say there are a 0.31 multiplied by 10 raised to 9. So whatever the number you will get, that much of the pulse, actually you are getting in your particular signal. Or we can say, there is a stuff we have like एक second में इतने 9, it means it's come about a billion. So that much of the billion pulse is going to generated in your system. That's just an example. Now somebody will just try to like that. I want to make make the speed of this particular transmission. I want to make it double. So frequency तो आपकी वही है, ठीक है, pulse rate भी आपने पता कर लिया. But how I can make it more, twice or thrice of that particular frequency? So to do that, what you are doing, previously you are presenting a one pulse with a one voltage level, one digital level. Now if you presenting such type of the 2 voltage level, okay, like 8 voltage level के लिए आप ऐसा signal आप बना रहे हो, you are creating a signal like this one. So in 1 voltage level, there are 2 pulses going to transmit it. So we can say for each same duration, previously you are transmitting a 1 pulse. Now you are transmitting a 2 pulse. Overall, your data rate is increased by 2. So whatever that previously is 0.31 into 10 raised to 9 is there, it is going to increase to 0.64 into 10 raised to 9. It's getting a twice of that. Okay. So whenever you are using a multi-level digital system, एक वोल्टेज लेवल को 1, दूसरे वोल्टेज लेवल को 0, ऐसा करने की वजह से आपको 2 ही वोल्टेज लेवल मिलेंगे और whatever the beat rate you have, that is going to double if you present in the same duration of multiple beats. Like आप 2 voltage level नहीं, 4 voltage level. अब ये 4 voltage level क्यों चाहिए? Why we need a 4 voltage level? Because for each voltage level you are having a 2 value. So if you are having a 2 binary values, so how many combinations are possible? 0, 0, 0, 1, 1, 0, 1, 1 will be there. So I need to give one level for 0, 0, another level for 0, 1, another level for 1, 0, another level for 1, 1. So I required a 4 level for that. So that's why I'm saying this is a level 4, level 3, level 2, level 1. So what I need to generate? I need to generate a 1 digital voltage for this one for this one, another for this one, another for this one. That's why it is having a such type of the 4 voltage level system you have. So to doing this particular stuff, your beat rate is increased by 2. 8, it's going to increase by that 16 beat per second. Have you guys got it? Yes or no? So over here it's already clearly given. Number of beats per level is identified like that. If you are having a number of level is 8, so log to the 8 you will get a 3. So you require a 3 beat each to transmit that particular level. So अगर मेरे पास 3 beat है हर एक level में, 3 beat है हर एक level में, like 1 0 0 1 1. So can you tell me how many such voltage level I required? Are you guys getting my stuff, or it is just going out of the bouncing or all the thing? हर एक पल्स को 2-2 बीट से रिप्रेजेंट करूंगा तो कितने लेवल चाहिए? 4. क्यों? क्योंकि ऐसी कितनी कॉम्बिनेशन बनेगी? 4 कॉम्बिनेशन बनेगी ना, 0 0 0 1 1 0 1 1. अभी ये सेम लेवल को 3 बीट से रिप्रेजेंट करता हूं तो कितनी पॉसिबिलिटीज होगी?
3.
क्या 3? 2 यहाँ पे कर रहे हो तो 4 हो रहा है, 1 कर रहे हो तो 2 हो रहा है, तो 3 करोगे तो क्या होगा? 2, then 4, and then
8.
8. Yes. Why? Because each voltage level is present with, let's take 3 bits, 0 0 0. तो कितनी combination होगी? 8 combination, 2 raised to 3. That's the overall written over here. So you can say if you are using a 3 beat represent on each level, so such 8 level you require. Such 8 level you require to present there a 3 beat system. And your beat rate is increased again by 2. It's increased to 32 BPS. Okay, because your system is again getting multiplied by the 2 from the previous one. Is it okay?
Yes,
Any
sir.
doubt?
No, sir.
Okay, any doubt, you can just open your mic and tell me, okay? Not an issue. So now over here, there are one example we have, okay? Let me first check how much time we have. It's 9:39, so we have enough time right now. Okay. So the example will be a digital signal has a 9 level. 9 level it have. How many beats are needed per level? That's the one thing. We calculate the number of beats by using the formula. Each signal level is presented by 3.17 beats. How? How much? This signal is just, this number is just unrealistic. Okay, like we don't have the 3.17 beat. There's always something in a numerical like 1, 2, 4, 1, 2, 3, 4, 5 like that. So this is unrealistic number. So how we can just modify this stuff, identify the level with that. So over here, what you are considering, what you are considering for this one, rather than, let's take, you are having a previously 9 level, and if you getting with this equation of a log to the 9, so it will give you the 3.17 something. So this is unrealistic. So what you are taking, instead of this 3, we are taking a nearby highest value, which is a 4. So what you are taking now? You are taking a 4 voltage level, 4 beat level representation. So 2 raised to 4, actually your system you need to convert to the 16 voltage level system. So to do the better transmission, your 9 level beat system converted to 16 level voltage system to transmit the proper beat. Okay, क्योंकि हम जब भी यहाँ पे इक्वेशन में ये करेंगे log to the power 9, it will give you something 3.17. So 3.17 beat हम नहीं भेज सकते ना. We need to send either 3 or 4. So अगर आप 3 भेजोगे तो क्या होगा? आपका बहुत सारी information it's going to loss because you require more than 3 beat. So better by adding an extra beat in that, 1 beat extra in that, transforming that 9 beat system to 9 level system to 16 level system, your sufficient amount of the data you can transmit it easily. Okay, so this is one example that how you can just send such type of the odd type of the leveling system you have, so how you can make it correct. Okay, so that's why it is a 4 bit is going to represent for each level. Assume that we are having we need to download the text document at the rate of 100 pages per minute. What is the required bit rate of the channel? So here there is one solution. Okay, so I'm just giving the solution also so you can get the idea. So 24, consider that there are 24 lines in one page. Okay, so that 24 line in a one page, and it is having a 80 character in each line. So 24 line in one page. In one line you are having 80 character, and such 1 character is presented with the 8 beat. Okay, so if such type of the calculation you are assuming like एक page में 24 lines होगी, हर एक line में 80 character होंगे, और हर एक character अगर 8 beat से represent कर रहे हो, so what is the beat rate over here? Beat rate over here is going to be identified like this one. The beat rate will be 24 lines, 80 character in one line, 1 character having an 8 beat, and such 100 pages in one particular minute. 100 pages in one particular minute. So it is going to be stuff like that. This is going to be a 1636. We can say 000 beats per second. Sorry, it's going to be coming as a, just a second. This is not a minute.
Sir,
just a second.
per minute होगा ना?
Yeah, that's why I'm saying that over here it's beats per second. So that question is beats 100 pages per second. I'm saying. Okay, now it is okay. Beats per second. अगर यहाँ पे minute होता तो ये beats per minute होगा, और फिर आपको क्या करना पड़ेगा? 163600 multiply by 60 second. Okay, when you just do this another multiply by 16, whatever the rate you will came, that is going to be came in a beat per second. Okay, but if you consider a second, so this answer is final. If you consider the minute, so this extra calculation you need to do in your system. Is it okay? So this is how the yes, please tell me.
सर ये जो पर सेकंड से पर मिनट में कन्वर्ट होगा तो मल्टीप्लाई करना होगा सर?
हाँ, मल्टीप्लाई करना पड़ेगा ना.
तो सर ये मीन्स
100 pages per minute.
ओके सर, गॉट इट.
हाँ, 1 मिनट में इतने हो रहे हैं तो सेकंड में कितने हो गए? लाइक सॉरी, यू नीड टू डू इट विद डिवाइडेड बाय 60. सॉरी, नॉट विथ मल्टीप्लाई, डिवाइडेड बाय होगा ना, क्योंकि ये ओवरऑल मिनट का रेट है. सेकंड में करने के लिए आपको उसको डिवाइडेड बाय 60 करना पड़ेगा ना. सॉरी फॉर दैट. या गॉट माय मिस्टेक. So overall we can say if there is, you are considering as this is a beats per minute, okay, and whenever you want to get it in a 1 second, so that you need to divide it with the 60. Over here it is 60 get cancelled, okay. When you just divide it with the 60, so overall you can get a stuff in a 1 second, okay. So these are the stuff we have, like what is the data rate and what are the stuff that we can identify. Another example that we will take, that is related to the HD television rate. So over here there are example will be like this one. In HD TV there are digital signal which is broadcast high quality video signal with the pixel of 1920 by 108. So there are overall how many pixels are there? 1920 by 108. So that much of the pixels in a one frame. And there is one rule is there, and I think there is a new thing for you. Have you seen any type of the frame rate in any camera, shutter speed, frame rate? Have you heard this type of the word?
यस सर, वो गेम्स में और उसमें आता है.
Yes. So if your frame rate is higher, can you say like that there are a very good type of the video quality you can capture? Okay, with a higher frame rate, a good type of the quality you can capture, as well as a data consumed by that higher frame rate is also higher. So when you just open your camera and start recording the stuff, they are having several options. Like, do you want to record in HD, SD, or normal? With which frame rate? Such type of the options are there. So in a standard way, whenever you want to see a 1 second movie, you need to do a such 30 frames per second. You need to pass in front of eye. That is called as a perception of vision. What is known as a perception of vision, and it will tell like that if you rotate a 30 frames per second in front of your eyes, then it is considered as a movie. So whenever you capturing a 1 second movie, it is nothing but it is capturing a 30 images in this 1 second. 1 second में वो 30 photograph लेता है, or it is going to be rotating so much fast, so you can see as a movie. This is a one thing over here. Okay, so if you want to identify what is the data rate, so 1 frame के अंदर 1920 this is a pixels are there. Such 30 frames you are transmitting or you are capturing. For each pixel के अंदर 24 bit हो गए. Now why there is a 24 bit? Because each pixel is made up of red, green and blue. So red के लिए 8 bit, green के लिए 8 bit, blue के लिए 8 bit. So overall it is going to be a 24 bit for one particular pixel. So 1920 multiplied by 1080 pixels, and such type of the 30 frames are there. This is a 1 frame. Such 30 frame, and each pixel is represented with the 24 bits. So overall it is considered as a 1.5 Gbps data. It is going to be consumed whenever you capturing any particular movie without any compression, without anything. So this is a 1.5 Gbps speed you have. But TV signal is going to reduce this 1.5 Gbps to 20 to 40 Mbps through the compression. अगर आप कोई कैप्चर कर रहे हो HD TV का इमेज, and if you are not doing any compression, you are capturing it as a raw, तो 1 सेकेंड के लिए आपको कितना डेटा रेट चाहिए? 1.5 Gbps data rate you require, which is very going to be quite impossible for any TV broadcasting station. So what they are doing, the TV broadcasting station, they will compress it to 20 to 40 Mbps, and then it is transmitted to your home. And your home, whenever you have that set-top box, is again going to decompress it, and it is going to give you the that high definition television or such type of the TV screen in your home. So here there are a name is come as a compression. So whenever you see that this is a MP4, there are a dot WMV, MKV. So this is nothing but this is a different compression format are there. Whatever the raw picture is going to capture in this compression format, your actual signal is going to be compressed, and you can see it in a you can say in a lower kind of the size of the picture. You already know that what the same movie, if you go with some of the extension of MP4, you go with the MKV, if there are something with related to the Blu-ray, so they all have, like Blu-ray will be 5 to 6 GB, while MP4 might be there is a 1 GB or 2 GB, while MKV or something another stuff which is a little bit lower. Another also like that WPM, several compression standard are there. You can search in the internet. But whatever the compression standard you are using, according to that, their data rate is going to reduce from original to that particular size of the data. Any doubt so far? Anybody? Any doubt so far? Please tell me. Any doubt, any question to anyone? Please tell me now. If it is okay with you, so now it's a 9:51. So it's time to write the summary. Everybody just write the detailed summary of this particular lecture, and then after write your enrollment number and name, and then you can go. If you have any doubt, any question, you have 10 minutes of time. You can ask me. Write the detailed summary, okay? Not just 1 or 2 line, but write a detailed summary. 2 line summary, Jayvik. मैंने 45 मिनट तक बोला यार, आप थोड़ा ज्यादा तो लिख सकते हो ना, प्लीज। After writing your enrollment number and name and summary, you can leave. Okay. Any doubt, Drumil, Gopal?